In today's video, we're going to be exploring Redis, a technology that is a key player in the world of data management and is widely used across various industries. Specifically, we're going to walk through how Redis works, how you can use it within the ServiceStack framework, and how you can get the most out of the ServiceStack.Redis library when incorporating it into your own .NET applications. First, some quick background on Redis. Redis is short for Remote Dictionary Server. It's an open source, in-memory, key-value data store. It's typically used as a database, a cache, and a message broker. One of Redis's strongest suits is its performance. Because it operates in memory, Redis delivers exceptional speed, which is a valuable trait in a world where quick response times can significantly impact user experience. Another great aspect of Redis is its data types and structures. Unlike other key value stores that only allow strings, Redis supports a multitude of data types such as strings, hashes, lists, sets, and sorted sets, offering a wide range of possibilities for extremely efficient data manipulation. Moreover, Redis supports transactions, replication, and has various levels of on-disk persistence, enabling a high availability and data durability. Another feature worth noting that sets Redis apart is its ability to perform atomic operations on some of these types. This includes appending to a string, incrementing a value in a hash, pushing an element to a list, computing a set intersection, union, and difference, or getting the member with the highest ranking in a sorted set. In short, Redis is a flexible, high-performing, and versatile technology that can really enhance your applications by providing fast data access and advanced functionalities. So now that we have an overview of what Redis is and what you can do with it, let's go through the ServiceStack.Redis library and how it acts as a bridge to leverage the power of Redis more easily within your .NET applications. ServiceStack.Redis is a .NET client library for Redis. It's a mature, feature-rich library that has been designed to provide a smooth interface to work with Redis from your .NET applications. This library abstracts the complexity of dealing with the Redis commands directly. Instead, it provides a more familiar and intuitive programming model for .NET developers. It's as if you're just dealing with regular .NET objects. One of the main features of ServiceStack.Redis is its support for Redis's advanced data structures. You can use the simple and clean API of the library to perform operations on these data types. This includes everything from strings and hashes to lists, sets, and sorted sets. Another major advantage of ServiceStack.Redis is its support for a variety of Redis services like transactions, pub/sub messaging, and high availability features such as replication and Redis Sentinel. The ServiceStack.Redis library also offers multiple types of client interfaces to interact with your Redis server, which provides flexibility for different use cases. This includes the standard iRedis client, which is a simplified, more straightforward client, as well as the iRedis typed client for a generic version that allows you to work with strongly typed .NET objects. These are the two interfaces we will be focusing on in this video to demonstrate the use of ServiceStack.Redis as a powerful tool for effectively bridging the gap between Redis and your .NET application. If you want more information about these two interfaces beyond what this video covers, you can check out reference.servicestack.net for our full reference documentation and the docs.servicestack.net/Redis website for more information on not only the ServiceStack.Redis library, but higher level integrated features like the built-in Redis admin UI in ServiceStack and Redis profiling. For this walkthrough, we're going to be using a locally running Redis server that's running in a Docker container. We will briefly show how you can get this running yourself, but depending on your environment, the way you connect to your Redis instance might be a little different. With that in mind, let's quickly get Redis running on our local machine using Docker Desktop. For those not familiar with Docker, it's a tool designed to make it easy to create, deploy, and run applications by using containers. Docker containers wrap up software and its dependencies into a standardized unit for software development that includes everything it needs to run: code, runtime, system tools, and libraries. In this tutorial, we'll use Docker Desktop to run a Redis instance on your machine. If you haven't installed Docker Desktop, you can download it from the Docker website. Once you have Docker Desktop installed, running a Redis instance is as simple as pulling the official Redis image from Docker Hub and starting the container from it. One way to do this is directly from the Docker Desktop UI. Once open, we can look for the search bar up the top and type in Redis and select the Images tab. Here we will see the official Redis image from Redis Labs. We can select it and then click Run. Here you'll be able to provide some optional settings, and we will need to populate the port field with 6379 so that our host is listening on that port. If you prefer the command line, you can run this command here, which I'll leave in the description. If this is the first time you're pulling and running the Redis image, Docker will download it for you. This might take a little while, but once the download is complete, Docker will start your Redis container on your machine. To confirm Redis is running, you can use the docker ps command and look for a container that's using the Redis image. Now we have a Redis server running locally on our own machine on localhost port 6379. This setup will be sufficient for all the examples we'll be going through in this tutorial. So next, we'll dive into installing and configuring the use of ServiceStack.Redis as a library and start looking at some code examples. We're going to create a new simple web project using the ServiceStack.NET X tool. We can do this with the command xnewweb space myapp. If you don't yet have the ServiceStack.NET X tool installed, you can install it using the command .NET tool install -gx. Once our new project is created, we can open it with our favorite .NET IDE. Once open, we will see the standard for project setup that's common to ServiceStack templates. If you're not familiar with this setup, just check out our fundamentals video about the ServiceStack app host configuration. Now we'll want to add support for using the ServiceStack.Redis library. An easy way to do this is you can actually use the X tool again to mix in some Redis configuration. This can be done using the command xmixredis. This will add the NuGet package for the ServiceStack.Redis library, as well as creating a configure.redis.cs file in your app host project. This file automatically configures your Redis connection using a Redis manager pool and uses the standard .NET Core dependency injection to have it available for use in your application. Here we can see we're adding an instance of a Redis manager pool to our services collection, and we're configuring it to connect to our local Redis server running on localhost port 6379. And that's it. We've installed ServiceStack.Redis, mixed in the Redis support to our ServiceStack application, and set up a connection to our local Redis server. With this setup, we're ready to start interacting with our Redis server from our application. Let's dive in and see how we can utilize the Redis client managers in our application. The most common way you'll access a Redis client is when building a ServiceStack service. From within a service, you can access the Redis property to access a Redis client. You don't need to interact directly with an injected variable, it's already available on your service base class. If you wanted to handle this yourself, you would use property injection in your service to have an iRedis client manager available and then call the getClient method. It's best to use a using statement when fetching a client so that it's disposed of correctly and the connection can go back to the Redis client manager pool. One common use case for Redis is using it as a centralized cache or cache for your distributed application instances. ServiceStack also provides a higher level of abstraction for caching through the iCache client interface. Let's explore how Redis fits into this picture. The iCache client interface provides a consistent API for interacting with caching providers. This makes it easier to swap out your caching implementation without changing your application code. By default, ServiceStack will use an in-memory cache client, which uses your application's memory for when caching some information. This can work fine if you only have one instance of your application running, but in a distributed scenario, it's sometimes better to have a centralized persistent server like Redis to handle your caching. By using the iCache client in this scenario, you can move from using your application's memory to using a centralized Redis server without changing your application code. Here is a quick example of using the iCache client. An instance of the iCache client is available on your service base class using the property cache. Anywhere in your service, you can then call cache.get or cache.set, providing a key, and for the set operation, you provide your value. The value can be a string or it can be an object that will get serialized. When you call cache.get, you then specify the type of that key so you can use it in a strongly typed manner. If our caching backend is provided by Redis, these operations would translate into Redis commands for get and set respectively. While the iCache client abstracts away the specifics of Redis, it can be beneficial to know what's going on underneath. Let's take a quick look at the equivalent raw Redis commands. Here we have the command get unique key, and if a key doesn't exist, we use set unique key and then pass in a string of the value. The simplicity of Redis commands is one of its most appealing features, and the ServiceStack.Redis library allows us to leverage this simplicity while still working within the comforts of .NET. A good example of this is the availability of the iRedis client async interface. Just by using the service base method of getRedisAsync, we can utilize the popular async programming model that many .NET developers have adopted for efficient resource utilization. And this model is also available for the simplified iCache client as well, using the cache async property on the service base class. If the iCache client doesn't meet your requirements, you can then look at using the Redis client. Unlike the iCache client, which is designed to provide a common interface for different caching solutions, the Redis client is designed specifically for Redis. Let's take a look at the equivalent operations to the previous iCache client example using the Redis client. Instead of using the cache property, we will instead now use the Redis property on the base service class. This will resolve an instance of the iRedis client that we can then use in our service. Just like with the iCache client, we're using the get and set methods to interact with our Redis instance. These methods map directly to the get and set commands in Redis we saw earlier. Just like the iCache client, we can also set an expiration time for a specific key. This is a useful feature when you want some data or cache to become stale after a certain period. All we need to do to take advantage of this is to provide a time span after the value we set for a specific key. Here, the result value will be unavailable or expired from Redis after 30 minutes. This maps directly to the set command and the X argument where the value will expire in the specified number of seconds. Just like the iCache client, the Redis client also works of persisting complex values. Here we have a custom class which is a plain old CLR object or POCO. That is, it's just a class that has properties for storing data and doesn't have any behavior. When we call the set method on the Redis client and pass in an instance of our custom class, it's then serialized to populate the string value in the set command in Redis. This is usually populated as a JSON string. When we use the Redis client to get the value, it is then deserialized, and this is why we have to specify the type when we fetch the value. One way to validate this is by using the official Redis CLI client. If we use the CLI to run our Redis commands directly, such as get unique-key, we can see our JSON serialized value in the command prompt. Another useful feature that's common to both the iCache client and the Redis client is the increment method. This will increment or create a value in a specified key as an atomic operation. This can be useful when implementing application features that need to centrally track the count of something within a distributed system, since it returns the resultant value of the increment in a single atomic operation. Meaning we have a guaranteed way to get the count of something happening across multiple instances of our application, since the value is stored and incremented in Redis in such a way that can't get dirty writes. For example, if you are implementing your own rate limiting feature to prevent clients from overusing a specific endpoint in your system, you could store the usage by user and API endpoint across time, and regardless of which deployed application instance the user hits in a load balancing scenario, the usage would be captured and measured centrally in Redis. So far, we've looked at basic features that are available on both the iCache client and the Redis client as well. If your requirements are more extensive than simple caching, the iRedis client lets us take advantage of some features specific to Redis, like its data structures, transactions, and publish and subscription messaging, to name a few. First, let's go through the different data structures we can use with the Redis client. Starting with lists, lists in Redis are collections of string elements sorted according to the order of insertion. They are implemented as a linked list, which means that even when containing millions of elements, adding a new element to the front or the back of the list is performed in a constant time, meaning it is very efficient. You could use them in your application for anything from storing a series of events to a stack or queue structure. Here's an example with ServiceStack.Redis. We access our Redis client from the base class of our service. We then call redis.addItem2list, passing in a key and a string value. We do this a couple of times and then we can call getAllItemsFromList to receive that list back. Dumping the list out to our console, we can see the order of the list matches the order of insertion. Next is sets. Sets in Redis are an unordered collection of strings. They're perfect for tracking unique items that are able to add, remove, and test for the existence of members in constant time, again very efficient, regardless of the number of elements contained in a set. For example, you could track unique visitor IDs on your website. The Redis client also has add items to set, which is equivalent to what we saw with adding items to a list. The main functional difference between a set and a list is that a set ensures unique values. We can see this in a simple code example. If we call add item to set multiple times with the same key and value, we don't get any errors and the set doesn't change in how many items or members it has in the set. So sets can be great for any task that requires deduplication. Next is sorted sets. Sorted sets are similar to regular sets but with a key difference. Each member of a sorted set is associated with a score, allowing them to be sorted from the smallest to greatest score. They're ideal for all applications where you have to take into account some kind of rating, for instance a leaderboard. For sorted sets, we have the method on the Redis client called addItemToSortedSet. It takes a key for the sorted set, a value, and then a score. When we call getAllItemsFromSortedSet, we also have the option to specify descending. That's because the data in Redis is automatically sorted when it's added to your set based on the score specified. Here we're simply using the length of our string, so when we dump it to our console, every time we see the full results, we can see the longest values are at the top and the shortest are at the bottom. Lastly, we have hashes. Hashes in Redis allow you to associate a field value pair within a single key. This can be perfect for representing a large complex object or more efficiently grouping values together. For example, if you're storing values where you base the key on a time and a fixed duration that only live for a very short period, expiring each key with the same cadence, if there are millions of them, can add up and take additional compute resources. So if you had a large number of IoT devices reporting back live measurements every minute where the most accessed data was the latest information, you could group all the values within a single hash for the latest time period, and then each IoT device would store its measurement in a field value pair within that hash. When it comes time to expiring that data from Redis, after say moving it to a SQL database, Redis would only need to expire one key per minute rather than one key per minute per IoT device. And using the ServiceStack.Redis client, we have familiar methods when operating on a hash as operating on standard keys. The main difference is we're providing a key for the hash as well as a key for the field within the hash. And then we can use increment, set entry, get hash count, keys, values, etc. If you prefer to use these data structures in a more idiomatic C# way of operating on collections, the Redis client has the lists, sets, sorted sets, and hashes properties, where you can pass a string key as if you were accessing a local collection. And they have specific methods available that map to Redis commands for each specific data structure. The choice between these data structures largely depends on your use case. However, in high-performance applications, it's important to consider the time complexity of operations for each of these data structures. With the ServiceStack.Redis client, manipulating these Redis data structures is more straightforward and intuitive, aligning closely with the native Redis commands while offering the familiarity and comfort of C# and .NET. One of the features that makes ServiceStack.Redis a highly convenient tool for .NET developers is its typed client API. This allows us to specify a type once using the as method to create a typed client. This client then has access to all the same methods as we've previously discussed, but now those methods and properties are strongly typed, giving us a much nicer and familiar way of working with our own data types. And this gets better still if you're using ServiceStack's ORM Lite, persisting the same data types between both Redis and your SQL database, because we can use the ServiceStack.Redis entity store methods on the client. These methods provide a consistent pattern based on your data type's class names and namespaces, as well as their primary key IDs. This can be an extremely convenient way of managing your shared data between Redis and SQL, as these methods automatically look for your primary keys to identify unique instances of your own data. For example, you might have a multi-step process of expensive operations to generate a report from your SQL database and then populate columns as the data is generated. Instead of clients polling directly against your SQL database, you could replicate the results as they're generated to Redis using the store method. We don't need to specify a Redis key here because our SQL database already created the primary key when the report was kicked off and initially inserted. The Redis client then uses this primary key value along with the class name and namespace to store that specific report. When the client then polls our service for the status and results, it only needs the same primary key of the report, and we can pass it to the typed Redis client's getById method to get our strongly typed instance of that report. By using Redis in this scenario, we can provide rapid responses to our clients for time-sensitive information, whilst also reducing the load on our SQL database, which might be busy generating that complex report. In today's video, we really have only just scratched the surface of what you can do with Redis using the ServiceStack.Redis library, but already we can see that it's incredibly useful and easy to use, especially in high-performance applications. And using ServiceStack.Redis with the wider ServiceStack framework, you get higher level functionality and integration like the Redis admin UI and the Redis profiler to easily manage and optimize your application. If you want to see any topics of Redis covered more deeply using the ServiceStack.Redis library, let us know in the comments. And I hope this video has been useful, and as always, thanks for watching.